Hey, real Dr. Spock. How's it going? Just doing a bit of research, actually. This is a diatom that we believe is a new species. The music is hype. Great. Burn August Red, hello. These are some samples from stream in Idaho, and they were collected by a colleague of mine. Her name is Anna, and the xylophone that swallowed a bowling ball? Something like that. Let's see. The chance that if I turn that, it will fit perfectly in my little box. I need to get a wrench if I want to make that happen. So this diatom's actually in what we call girdle view, side view, and it's actually two diatoms. It's not a zipper, I promise. The diatom. It's skeleton anyway. This is what they look like in prepared slides. So you may have seen them in my slides or Pacific Plankton, where we were looking at them at what I consider to be very low magnification, which is like 100 times or something. This is actually that scale. It's that's an accurate measurement right there. So diatom's about maybe 70 microns long, 60 microns long, something like that. I don't recommend eating the diatoms, but if you're a doctor and you recommend it, then when people get the indigestion, they can talk to you about it, not me. Let's see. I'm gonna actually, I think, take pictures here. How well that turned out. Oops. Well, I think there's a picture there, so there's that. We'll just roll with it. Seemed like it probably turned out. There's actually two diatoms there, as I mentioned. Every morning, probably a good idea. It's a little tiny one here, really skinny one, next to a really fat one. That happens because this diatom split didn't really split right down the middle very. Got a little bit more material than the other. I think. Well, I don't know how to help you about the patience problem, but I think I want to try to get one more photo, just highlighting the separate valves here. Can it be good? Now I'm gonna reverse where I am. Out to the 20x, I think. So taking pictures and looking at diatoms up close needs to be done at 1000x, which on my microscope version. That means I have this annoying issue where if I want to zoom out, I basically need to clean the oil off the objective. And start over, basically. So diatoms are sapient, or do they move off of reflex? They're just they're single-celled organisms, so they don't have any initiatives. You know, they're just responding to things. That was the one that we were just looking at right there in the center. Now I'm back out to 40x. This diatom is a Gomphoneis, characterized by this sort of pie wedge shape that you see. Sort of, you know, shaped like a pie wedge. In girdle view. And in valve view, we'll see one in a bit. Yeah, they do have a chemotaxis, and they also have a phototaxis. Mario. And also, I think yeah, there you go. I made you your own bot command. Welcome in. Dreamers who do science get their own bot command. Channel. And so normally we look at these at, you know, from the living stuff at like maybe 200 to 400 times magnification, and right now we're looking at it, scale bar's wrong again, sorry, this is 200 times magnification, or roughly that. And I'm just looking for that same diatom we just saw, but I'm trying to characterize it, because if it's a new species, which I think it is, we need to have a lot of pictures of it. And it's pretty uncommon in the samples. So, and I think actually there's two different types of Gomphoneis that are large that are in this sample. And one of them's actually a Gomphoneis and one's a Gomphoneis. And the one we were looking at right there was a Gomphoneis. I think the other one is a Gomphoneis. And the thing that we might confuse it with is this guy right here. I think that's a Rheucosphenia. I don't think that's a Gomphoneis at all. They're not actually an animal, Spock. There's something in between a plant and an animal, because they're photosynthesizers, or most of them are. We tend to think of them more like plants, but because they can crawl around, I tend to think of them a little bit like animals. So, not all of them can crawl around. The ones that we're looking at right here, almost all of these can. So it's a little weird. They don't conform perfectly to our idea. Also, that's a fragment of one of them right there. That's the Gomphoneis, the other one. A little bit bigger. A plantimal, yeah, that's what I like to call them. Like a plantimal. Sometimes people use the term protist, but I don't really like the term protist. It's just like a garbage group. And I'm not a fan of garbage groups. I feel like we should just give it its own name. They're diatoms. They're just their own thing, basically. Here's another one. We found another one in girdle view right here. Here it is at 40x. So I just jumped up double the magnification. And I can cheat a little bit here at 40x and show it to you at a much higher magnification by doing this. It's using my optical zoom on my camera. This is the Gomphoneis, not the Gomphoneis. So, same sample. Venus flytraps move. I don't know how a Venus flytrap moves exactly. I mean, I know what causes them to move. They have little hairs in there that detect when things are touching them. Well, not hairs, but like plant hairs. And when they're touched, basically it causes it to close. So as long as we're here, that's Gomphoneis, a different genus. This is Acanthidium. That's Gomphoneis. These are all Gomphoneis up here. That's a little tiny Gomphoneis, a different species. And this is our big monster, Gomphoneis, here. And that is Planethidium. So there's a bunch of different diatoms. I only care about these ones right now. Maybe later we'll go back and look at other things. But I'm gonna put on the oil objective again. What area was the sample taken from? It was collected from a stream, or actually it's more like a river downstream from a power plant in Idaho. And a colleague of mine, Anna, who may show up when she sees my message, collected them for me and sent them to me last week or the week before. Because we had some other material from the same site, and a little bit of oil left over on the objective. I think it's enough that I don't need to actually add anymore. She had been looking at some of the samples, and we realized that these giant Gomphoneis were something interesting or special, probably unknown to science. And we started to try to chase it down from the samples she had, but there wasn't much mass in it. So I actually tried to get somebody just by asking some people on Twitter, hey, are you near this area? Could you grab me some material from this site? And they went out and grabbed some material for me, which I was actually really surprised by. But we didn't find any of these. And I don't know if it was just because of where they sampled or because it was winter time.
Good news, everyone.
Hey, Queen. Hello. Welcome in. And so, for the Diatom alerts should be on the top, bottom. Base cam. And so we went out and she went out and collected some more material from the same site, and she actually collected about 12 samples. And this one that we're looking at right now just turned out to be a winner, both species that we're looking for. So kind of cool, but we have the live material, although I think most of the diatoms are probably dead at this point. You know, I basically processed it in nitric acid to get rid of all the organic matter. They smelled really bad. They were, you know, shipped and then spent a couple extra days in the hot sun, I think. And when they got to my lab, they were pretty bad. So I kept them in the hood basically the whole time, and every time I would open them, everybody in the lab would be like, oh god, what does that smell? And it was these things. So what are we looking at? We're looking at a diatom in the light microscope. So these are the skeletal remains of the diatoms. The diatoms are a type of algae that live in water and all kinds of water. And these ones that we're looking at right here this is Gomphoneis. And it's one of two different probably new species that we're looking at from this material. And I'm just working on characterizing it, getting some pictures of it. Diatoms are interesting because they have a silica skeleton. And the silica skeleton basically allows them to be preserved. And I'm actually a paleoecologist, so I try to use that to reconstruct past environments for the most part. But I'm also sort of a taxonomist. So I use my scanning electron microscope to identify and describe new species when we find them. Sorry about the brightness, I'll fix it. Right. So there's the specimen we were looking at, right there. That's in 100x magnification. It's right there. But we were zoomed in super close. So I think I was going up. Yeah. Oh, and here's the other species that we're looking at, and this one's actually in valve view. So we've been looking at them in girdle view, which is sort of like side view. And this is the other species right here. This is what they normally look like, kind of like a submarine. I'm gonna zoom in. You'll start to see it a lot better here in a second. So that's the shape that they have, like a bowling pin or a submarine, basically. And jump up to 400 times magnification. You can start to see the details. So I just thought I would sort of share my work a little bit. A little bit like a corn cob, yeah. A good observation, Ion. We can zoom in and look at it. This is the sort of characteristic appearance of a Gomphoneis. Gomphoneima was the one we were looking at, and this is the Gomphoneis. They're closely related genera. This right here is a line created by something called an axial plate, and we'll look at this in the SEM probably next week. So if you want to hang out, catch one of my SEM streams, it'll probably be Wednesday's stream. I think we'll look at this this guy. The axial plate is sort of like a silica covering on the inside of the valve. The Diatom skeletons are made out of silica, so they're a little uncommon. A lot of the fossil organisms are usually calcium carbonate, so that was a good guess, Mario. But diatoms have silica skeletons. So these samples were prepared by putting it in nitric acid, getting rid of all the organic matter. There's a lot of plant material and stuff, and then we rinse out the acid basically, and just dry them onto cover slips, and then we mount them in a special medium called this one's called Nafrax, which is basically like roughly a highly refractive index epoxy-like thing, kind of like airplane glue or something, but and then we cure it on a hot plate basically. So these are fixed slides. The diatoms are dead, the skeletons are all we have, and it actually allows us to see a lot of the detail, like this thing right here that you can see in the middle of the diatom. So these are, on a diatom, this part's called the raphe, and these are called stria, these things. And that thing right there, that you see the little dot, is actually called a stigma, like, you know, Jesus had stigma in his hands, sort of thing. And this line that you see where the two striae sort of divided, it's actually, like I said, it's an axial plate. It's like a thin silica covering in the inside of the diatom. We've been trying to get a nice inside view of these things. And this open part out here doesn't have the covering over it, so there's a line, a sort of shadow of that silica plate that you'd be able to see in the SEM, but you can't see here. And then also these things would be little tiny pores, but they're in rows, so we think of them as stripes or stria, which the sort of Latin name for stripes. And then this thing is the raphe, as I said. It has 2 branches on each valve, a branch that goes that way and a branch that goes this way. And then we'll sort of look at some of the characteristics of a Gomphoneis right here, which is it has this little set of tiny pores right at the valve end. These are called Apical Porefields. And then you can see this sort of zigzaggy line is where the raphe sort of ends right there, and it splits the apical porefields in half. So it runs right down the middle of them, and it has a halictoglossa, which is creating this shadow, which we would also see if we were looking at it in the SEM. And if we go up to the other end of this guy, you'll see that it's shaped differently, and that's actually like a bowling pin or a submarine. Basically, it has a different shape on both ends. We refer to this as the head pole, and that one down there is the foot pole, because this end does not have apical porefields. But it does have something kind of interesting that you can see right here. These 2 little lines, these 2 bright spots you see right there, are actually little horns. And that actually makes this diatom really interesting, because there's not a lot of diatoms with little horns that come off of the top of it that are in this group. So that was one of the reasons I started looking at these and thought maybe they might be a new species. And I sent them off to have a friend of mine who's a Gomphoneema expert take a look at them. And they agreed with me that this is probably a new species. So we're working on characterizing it, and then we'll probably send it off to my colleague to have them help us, because it's his specialty. And maybe we'll try to publish that paper sometime this year. So, kind of looking forward to getting this thing checked off as a
pull up a chair.
A project, because we started this back in January or something. Thank you for the follows. Everyone. Thank you both for the follows. And we're going to zoom into 1,000 times magnification right now. So hold on. I've got to make some minor adjustments to the actual view. Switching over. We're in differential interference contrast view right now. So the diatom will become focused here in a second. Then we can take a look at those features that I was just talking about a little bit more clearly. That's the stigma. These are the raphe branches, and then you can see it's asymmetric, so what's down here doesn't show up here at all. You can see really clearly that line that runs down the valve about 2/3 of the way out. This is the axial plate. The plate is this whole piece right here, creating the shadow, and then the apical porefield and striae are here. And we can zoom in and take a look at some of these features that you can see. Just snap right in with the camera. This part. So you can see it's actually composed of a series of little holes, and they are biseriate. They go back and forth. One hole here, one hole there, back and forth. And then this is the stigma right here. So it's just a little hole that goes through the valve. And here are the raphe ends.
Good news, everyone!
So we can see them very clearly at 1,000 times magnification. Now I'm really zoomed in as well with the camera, so a little bit clearer if I zoom out maybe. This over here is Gomphoneis, as I mentioned. It's a different genus altogether. And then let's look down at the base. See all the features that we're talking about clearly once. Here it is coming in, that's the raphe, and it's at a different focal elevation, so it comes in this way, and then a little zigzag right there, and then it runs in between these little things, which are the apical porefields. So they're on one end with the apex, and they're a bunch of little tiny holes, so we refer to it as a porefield. And if you're wondering what do these do, this is how it attaches. So this diatom actually lives on a stalk. Hey Spicy Juan, how's it going? And also hello to Jukes. I think I said that, but it again. And then You thought it was a zipper. It's not a zipper, Spicy One. Looks sort of zipper-like, though. Yeah, so in here, the apical porefield, and right where the raphy ends internally is this thing in this helictoglossa. And let's go up to the other end of it. Just gonna move the camera. It's easy. Slide, actually. And take a look at those little horns. And when we see one in girdle view, you'll actually see.
Hey, Maori Souri.
Thank you for the subscription. Here's those little horns that we were looking at. They're right here, picking up, and they just sort of curl outward a little bit right there. So this is I call this like a unicorn diatom. That's we call it the Gompho monster because it has these little horns like a monster, and also it's enormous. So thank you very much for the subscription. I should point out that all the money that comes in from subscriptions or anything else, cheers or whatever, I just donate back to my lab for undergraduate and graduate student research. I don't make any money from my Twitch stream at all. I pay taxes on it, and then basically I use it to buy supplies and things for my students. So you're supporting student research with anything that you do. It's all, I just do this for the fun of it. So you can see the axial plate here, and then these two little horns stick there, which we'll see one of them if we get a girdle view of this, which we should eventually. So I'm gonna get it into focus again right in the middle. Oops, sorry. Need to get the middle in focus, and then I'm gonna take a picture and we'll move on to the next. I need to get enough of these sort of characterized. There you go. That's actually sort of around 3,000 times magnification, but it's like more like 1,000 times magnification. Optical zoom makes it bigger, basically. But it looks like this in the light microscope to me, so I think it's nice for, that's what it looks like to me in the light microscope. When I look in there, that's exactly what it looks like to me. It's very clear. And so it's easier for me to take a picture of it, basically. I've got my camera mounted on the top of this microscope. We got a nice clean image of that central part, and then I'm going to move this a little bit so we can get a nice clean image of the apical porefield, hopefully. Right on it.
Hey, Maori Souri.
Also, thank you for the subscription, Burned August Red. Both of those, although I think probably I need to move that back and do that optically as well. Quite so off the screen because this thing's bigger than I thought it was. Normally I stream from, well, I don't say normally anymore, I do whatever I want, but I usually stream from a scanning electron microscope. So if you like to see things in detail, the light microscope here that I use is beautiful, takes beautiful pictures, and together with my camera makes a great combination. But if we want to see the real detail for this, basically the scanning electron microscope is where it's at. And I stream from the scanning electron microscope on Mondays and Wednesdays, afternoon and Eastern time. Light microscope streams are just whatever I want. So, let's see. I deserve a sub for teaching us, so thank you. And let's see. This is something alright. It definitely is, Steam Skinners. Cool. A bunch of diatoms. Are there any organisms that move super fast? Well, everything in here is dead. We're looking at sort of a graveyard of Diatom Skeletons, so none of this stuff will move. But I do have some material over there from a pond that I could pull in if you're interested after I get some good pictures here. How much is this microscope? The one that we're looking at right now is the a Leica DM2500, and that is a $20,000 microscope. And then the camera that's attached to the top of it is an Olympus OMD EM1 Mark II, and the body cost about $1,000. So pretty high-end pieces of equipment. These are actually camera belongs to me, but the microscope belongs to my lab, not me. I just have it at home. It's not the type of microscope you could buy unless you're a research scientist, basically. But I have it at home because I'm doing research at home, and I was doing research at home through COVID. So, the scanning electron microscope in my SEM lab costs about $160,000, and my university bought it for me. I wrote a grant, basically, to the university, and it was the top-rated grant proposal that they had, and so they funded me. And so I have my own SEM lab, and then I have my own microscope lab at school as well, with 5 different microscopes, and then another lab that I have access to that's got about 8 more that we could use. But this is my my home version of it that I've been using since COVID started, basically. Do that. I want to switch back out of oil immersion. I'm going to just clean off the oil so we can move around a little bit more. My Instagram for the SEM or my Instagram for my own photography? Because I have 2. The lab has an Instagram, which you can access from the SEM images. That's this one. And I do all of the image coloring that's on there, so SEM images come out black and white. And then if you want access to my actual Instagram, it's the lower one on there. That's my I take pictures of things with my camera. And sometimes I will stream as hello Sam, welcome in. As Sam knows, I also stream sometimes birds or the moon or anything I want, basically from my camera. And I do macro photography a lot, and a lot of telephoto, birding, that sort of thing. And I'll just stream directly from my super high resolution camera to Twitch. So that's mostly fun for me as well. Sorry, jumped a little bit. Sorry about the brightness. I need to start looking for more material here. So we'll just keep looking around. We're at some really low magnification for the moment. And try to fix the image quality a little for you. And I'm just gonna go browsing around looking for more of those little bowling pin shaped things. We'll stop and take a look at some other diatoms on the way, because there are some other cool diatoms in this material. But I do need to get some work done, so we're actually you're actually sitting in on my my home research time. I had one of my students prep, or 2 of my students actually prep some material for us to look at home. See what that is. The Ricosphenia. Also Ricosphenia. So that I could try to get some research done. I do a lot of work a lot with my students during the main part of the day right now, so I haven't been getting a lot of research done, and I kind of check these samples out. Nope. And try to get some images for my friend Anna. She'll come in and visit us. Yeah, it's a pretty awesome microscope. Actually, I have 3 of these. 2 more in my lab right now. And then if you've been to Pacific Plankton Stream, some of you I think probably are coming from there. I have 2 more microscopes that are like the one that she uses for my students as well. So if you don't know Pacific Plankton, you should probably give her a look and a follow. She does similar stuff as she looks at a lot of living material. I have I'm a research scientist, so I have facilities that a lot of people don't have. My own, like I said, I got a lot of microscopes in them. I've got a stereo microscope, and I've got these. One we took a picture of before. We're zoomed out, so I think we're actually looking at it, because that one has the same double back. Venia? Yeah, so if you're not following Pacific Plankton, does a lot of live microscopy twice a week from her home, and some amazing images. Also has a camera hooked up to her microscope, a nice one. And if you really like microscope streamers, there's a whole list of them here that you can hang out with, that I've put together for you. I'm a fan of all of these people, and follow all of them. I recommend every one of them. They do their own, each of them does their own sort of thing. So you're gonna go on YouTube and learn to build your own SEM. You can. I won't stop you. And then you might also consider Volcano Doc. I don't know if she's still on, but she was actually streaming from a lab computer microscope as well today, looking at volcanic minerals. So she's working on trying to get a home microscope to stream stuff from the home. And then I think once she has that, she will be streaming regularly from a microscope, looking at mineral stuff. And I think I might try to do a little bit of mineral microscope maybe sometime this week, coming up. Not this one that we're in, but the following one. Because I think people are kind of interested in seeing what minerals look like in the microscope. I'm also a geologist, so I'm actually trained as a geologist, and I do sort of paleontology on diatoms, or these little things we're looking at. They're kind of rolling by you. There's probably tens of thousands of them on this little slide that we're looking at. They're highly concentrated right now. Guys we want, and I think this is actually the Gomphoneis turtle view, but I don't know for sure yet. Not sure what that is actually. Maybe it's the other one. A little small. Yeah, it's the other one. That's a Gomphoneis. Has a little bit of a blue color right now. That's actually just a physical color from the light refracting through it. So go with this sort of blue color right there. They don't actually have color, they're clear. So that's a Acanthidium, that's Planethidium, that's Gomphoneis. That is, can't tell what that is actually. Not totally sure actually. That's Diatoma Mesodon. And oh, that's a fragment of. And then this is the guy that we're looking for. Well, everybody wants to buy an SEM. If I could afford one, I would buy one. Not rich. My lab is rich. And only because I wrote grants, basically. Let's take a look at this one. The pretty blue color will disappear when I move into to 100x on it, I think. And also if I switched it over to the appropriate filter. That's actually the 40x filter on it right there. You can zoom in this way, but it's not going to give us as clean of an image. It's actually a little bit lower resolution than it would be at 100x. Get the oil to just roll through that for us. See, I need to add oil. Got it. There's a little bit that's always attached to the lens, so I try not to add any more if I. Serve it. The Gomphoneis for sure. Changing some settings so we can see it a little bit more clearly. So if I have the matching filter matched, then we'll zoom in, see what it looks like. And the reason that I know that... Yeah, the reason I know that's the Gomphoneis and not the Gomphoneis is the little horns that we were talking about would show up right here. Add the Gomphoneis. Instead, we know this is the Gomphoneis. Also, the striae are a little bit different. Well, the characteristics of them are a little bit different. See the horn and striae character a little different, and this one's a little small for that other Gomphoneis. I will get to your question. I see there's some people. The channel name is Applied Science. He builds some. Oh yeah, that guy. Yeah. Everybody always brings up the guy on YouTube who builds his own SEM. I just bought mine, so I'm not an engineer. Anything in particular that I'm looking for? Yeah, Sugar Fatty, I'm actually just trying to get some characteristic images of this species and the other one that we just looked at. These really big Gomphoneis are really interesting to me. They're probably both new species. I'm going to describe them after we finish taking pictures and get them on the SEM later this week. Need to get some inside views is what I'm really missing. I actually have some other light microscoped images of it. What I really don't have is an internal view on the SEM. So the SEM actually allows us to look at it in 3 dimensions. And so I don't have that view yet. I really need one in order to describe it. And then also it would be helpful if we had enough pictures that we could figure out the sort of size range that they occur in. So I'm trying to get a sense of the length and the width, but the width of the girdle view isn't helpful. So I just need the length from this picture. So I'm kind of trying to balance between getting the length perfect and also making it so the picture is clear. Just taking some pictures. Help with our characterization to get it more complete. I'm going to move on from this one. How old are these slides? So these were collected from material that used to be living 3 weeks ago. So these are very young samples. This is a living diatom. The ones on the slide are dead, but the species is still alive. Anna went out and collected these. She was on her way to Yellowstone with her family, I think. And she stopped on the way at the site and collected these for me, so that we could get some, hopefully get some more SEM images and get some internal views. That's our primary objective, basically. Do I have a favorite diatom? People ask me that question quite regularly, actually, and my answer is whatever diatom that I most recently described is my favorite. And I think in that case, let's see. Stephanodiscus coruscus is the one that I most recently described. So that paper came out in 2020. And I haven't described any new species that have been published so far this year yet. Other publications, I've got 5 papers, I think, so far this year. And I've got another 4 papers that are either in or they're about to go in for review, or they've been reviewed and we're working on revisions for them. But none of them are describing species. So, so right now that's my favorite, because it's the one that I described. So it makes it more interesting to me to actually be connected to it like that, to be the authority for it. And this is the other one. This is the Gomphoneis. So this sample has both diatoms, which is nice. And I can tell that this is the Gomphoneis because the striae look a little bit different, but also, you see this thing right here, this little bump? We'll zoom in, you'll see that's actually the horn I was talking about. They have a little horn that's growing off of the front end of it, and you can just see a little bit like a single horn in girdle view, but in valve view we saw it sort of forking. Gonna zoom in on that, and we'll keep taking a look at it. And as it gets closer, you can see right there, it's like a little bump, but it's actually a horn that sticks up. See the little horn that's sticking out? That makes this one pretty interesting. So, like I said, pretty uncommon. And then we have some species from Africa that I'm working on describing as well, or maybe just moving to a new genus that has that exact same horn but is a different organism. Have you ever discovered something live on stream that you had not in the lab? This was just, we figured out this was a new species on stream. This one that you're looking at right here. We just haven't described it yet. That was like January, I think, or maybe October? A while ago. Somewhere in between January and October. We realized it was a new species on screen. So, and I think we've done that. I think I have like 3 other species that we found recently on stream that are super old. They're 10 million years old, that are brand new to science. Yeah, I get to name them. So I'll probably be the person who names these species, or I'll ask Anna to help me do it. But it'll be one of the 2 of us that'll probably describe and be the primary authors on this. And we'll get to put the name on it as well. Yeah. That's a nice perk. Again, I am mostly a paleoecologist, so most of my work is actually looking at old diatoms and trying to figure out how they represent past climate. A community name? We could. Could put it up for a community to think about. Be fun. Okay, so the oil's gonna roll over this, and then I need to do some adjustments again. So work on those for you. So a little bit of microscopy, but I think you'll be able to see very clearly what I was talking about as the horn right now. And especially when I zoom in on it. There it is. There's the little horn just sticking up right there. It's like a blade more than a horn almost. You can sort of see it. And when we find another one in valve view, when we're looking at it from the top, I'll show it to you. Hey Saturn, how's it going? Butt chugging germy germ? Yeah, that's why we would probably not leave it totally up to the community, or we'll get Diatom make Diatom face. But you can see there's the horn right there. It's sort of like a bladed shape to it. And there's 2 more in here, because that's actually 2 diatoms. So there's one valve here, one diatom here, and the other one here. And it's got a horn, and that one's got a horn, this one's got a horn, this one's got a horn. Each valve has 2 horns. Yeah, exactly. Alright, so I'm going to zoom out, get some picture of this in-girdle view for us. You can see how big this is. Part of the reason we call this Diatom monster, Gompho monster, is it's 100 microns long, which is basically just 1/10 of a millimeter. But like most of the diatoms that are around it, like these little guys, these are sort of the typical range of diatom sizes that we see for this group. This genus, Gomphoneis, doesn't usually get quite this big, and also that other one that we saw, the Gomphoneema, it doesn't usually get quite this big.
Daddy is cute.
Oh, it's Pacific Plankton!
Daddy is brave, and Daddy will not stop.
Oh, Pacific Plankton. I was just telling everybody here they needed to go follow you. She's trying to catch up to me in follows, so I think you should help her out. She's got to get to, 2,000. And, so go follow her twice to every one person who followed me, and then she'll catch up. Hey, Froza, how's it going? In no time, she'll catch up. It's a diatom being split. There, making 2 diatoms. Haven't quite separated yet. But this is kind of cool because you can really see the outer diatom. This used to be one whole diatom, and when they split, it forms one new valve inside here, facing this way, and one new valve inside, facing this way. And then they split down the middle right there. I have 2 diatoms where you used to have 1. And you can also see very clearly, so this is the outside valve that used to be connected to this one. And you can see it's just a little bit bigger than the one over here. So, we give these special names, but you can just see this one's a little tiny bit bigger. But then the ones that are inside are also a little bit smaller than both the ones that are attached to them now. And because of that, diatoms get change their shape over time. They get smaller, basically. Yeah. You should, if you didn't catch that, there you go. There's a link for Pacific Plankton. Just go there and mash the follow button and, hit it once and then find a friend and have them hit it once so that she can catch up to me. It's important. Look, Pacific, it's the Gompho monster. It's Return of the Gompho monster. It's like a new movie based on a movie we've already seen. But now we've got more of them in our sample. And hopefully we'll be able to find some that are split open, and then we'll be able to finish describing this. How long do they generally take to split? Diatoms can sort of divide, like optimal conditions, everything perfect. Most species maybe once a day. Some of them can actually go as many as 8 times a day. Typically the plankton divide a lot faster than benthic stuff because they can get nutrients. Are these are prehistoric. The diatoms themselves that we're looking at right here are historic. They're from 3 weeks ago. But diatoms are about as old as dinosaurs. So they've lived through the Cretaceous, Jurassic periods. That's where they sort of evolved, or at least that's where we think they've evolved. And they've lived since then. So kind of roughly as old as dinosaurs, although, that's a wide range. Some of the dinosaurs are closer to us than they are to each other in time, if you think about it. Yeah, they've lived quite a while, and while the dinosaurs have evolved into birds, the diatoms have just evolved into other diatoms. Yeah. So I'm gonna zoom back out. Let's see. I'm gonna make it easy on your eyes. Just turn my light off. And then I'm gonna clean off the oil again because we're doing this back and forth between the oil immersion and air immersion in our sample. Super annoying, but it's easier to find material this way. Thanks. And then, yeah, there you go. That was these two little guys right here, the ones we were just looking at. We're now zoomed out to 100x. So if you wanted to see that, we're in that sort of a size range. Are you saying that it's actually finger-licking good Kentucky Fried Dinosaur? Yes. Yes, exactly. It is. Some dinosaurs are birds. All birds are dinosaurs. Some dinosaurs were also birds. Or they became birds. So all things, including chickens, were at one point evolved from dinosaurs. Aha! Here's one in Valve View again. Found that actually relatively quickly. I'm excited about that. I'm gonna fix up the image for us again here at 40. Kind of zoom in and take a look at this diatom. As I mentioned, there's a Gomphoneema and a Gomphoneis that we're looking at, and this is a Gomphoneis. And you can tell that because it has that axial plate, creating that shadow line right there, and then stigma that's on both of them. And then this one will have horns down here, because the Gomphoneis has horns. I don't know if they've reached their final form. I don't think that's true, but they've reached a form. Are there species that have not evolved since the time of the dinosaurs? I don't know the answer to that question. I think probably not. I found a diatom the other day in the 6 million year old stuff that we were looking at. That's Miocene, so that's a lot younger than dinosaurs. And it had something that basically looked like a modern diatom. It looked like Olicocyra italica. And I posted that picture to Facebook, but I didn't think I posted it anywhere else. So, or maybe it's on Instagram. Yeah, it's on Instagram as well. Okay, so this is it at 40x. You can see these things are monstrous relative to everything around them. And we're going to zoom in and take a look at it at 100x. 1000x. Maybe there's just not quite enough oil on there. There it goes. It will get fixed. Promise. Either this or I add more oil manually. Like maybe I put more oil on. Little bottle of oil I have is on. Let's look at this for a little while longer. I just want to take a couple more pictures and then I can try to put on some pond material. I don't want to spend the whole day looking at the same 2 diatoms. I feel like everybody would get bored, except for me. Go. See, there's 2 valves there. It's in focus, and see features focus, and you can see. So I told you if we looked at it from above, you'd be able to see the little horns. And they're actually right here and right here. And when we looked at it in girdle view, they were standing up and sort of off of the face of the diatom. But in valve view, you're looking at it from above. So like a map view versus like a landscape view. And in the map view, that's the 2 little horns right there on the head pole of this diatom. We are now, we're 3 times that actually, so they're here. You can see it's got the little horns on it. And then this giant Gomphoneis also has, mentioned the same features the other one hasn't. We haven't actually seen the other one in valve view yet. Little stigma, here's the raphy, here's the striae, all the things that we were talking about before here. Let's see if I... did it the right height. Snap a picture of that. And right on. See if I can find one of the valve views of the Gomphoneis, not the Gomphoneis. And then we'll switch over to the pond sample a little bit. Let's see. What are those coffee bean looking things? I think those are Gomphoneis that you're talking about, that are the other diatoms. How many chromosomes do they have? I actually don't know how many chromosomes they have. I don't study the chromosome part, but my friend Itzy does. Itzy field the questions about chromosomes for us. Alright, let's see. I'm gonna cruise around and try to find one of the other Gomphoneima. See if we can find one of them. We just find the other stuff, we won't stop. Oh, I think that's one of them right there, actually. Oh. That's a Navicula, actually. Even the right genus. Receptive. I think that is one, but it's kind of cruddy. Little. It's very little, actually. Like, smaller than I was expecting. There's other little diatoms all over the screen are mostly Gomphoneis. They are a type of diatom that mostly grows on plants, including other diatoms. They can grow attached to them, move around on them a little bit. And some other cool diatoms in here. Sort of an ulnaria right there. That is a Gomphoneis. This way off down here, that's a Gomphoneis. The one that we don't want to see. We've seen enough of you already. Take a look at this little Cimbella while we're here. This is, I think, Cimbella mexicana. Some variety of Cimbella mexicana. We'll just go to 40x for Oh, I don't think it's Mexicana, it's something else. Yeah. Closely related to Mexicana. In the same group. Pretty small. The trilobites are no longer around with us, Sam. They went extinct. Fewest is 8, largest is 130. Taxonomy of diatoms more focused on morphological traits rather than genetics. Yes, that's because people have used the structure of the Diatom skeleton to describe species for the longest time, and there are a lot of diatoms, tens of thousands of diatoms known, and like 5% of them have been analyzed genetically. In fact, that's Mallory's project, so if you are a regular follower of the channel, you'll remember Mallory's my lab technician. Her project for the summer is actually to look at an entire genus that nobody's even looked at any of the species in it for genetic analysis before. And she's working with my friend Itzy to do that. So that's just an example. But there's actually a lot of genera even that we don't have DNA information about at all. So as we sort of progress, we'll probably add more and more DNA analysis into the sort of standard toolkit for analyzing diatoms, but at least at present, we only know them as species by, or most of them, by their ultrastructure of their skeleton. And part of the problem is that the fossils that I was talking about, the things that have been around for a long time, those you're not going to get DNA information from. Not definitively, anyway. So it's pretty difficult to incorporate those into the mix. Gomphoneis. See, it has the axial plate. You can see the axial plate. We're not even zoomed in. That was that little one that we saw before. That is a Pleurocyra right there. Brownish looking speck. Great. Here. Pretty cool diatom, actually. Got a little bit of optical color as well. It looks kind of purplish. Got some junk inside of it. They've got these two like bug-eyed shaped things on the outside edge. This one's broken. It's supposed to be oval. Pleurocyra laevis is the species, and I can say that with confidence because I think there's only one Pleurocyra in North America. I think there's any other ones that people have described from North America, so pretty sure it's laevis. There's another one of those Gomphoneis. And there's a half of a Gomphoneis that's been broken. That's Cimbella. That's the Pleurocyra in girdle view right there. So this little thing right here, that's Pleurocyra and girdle view. We saw it sort of from the top. And that's actually a Navicula again, trying to trick me. Another. That's actually Ellerbeckia from the top, or from the side. Yeah, that's Ellerbeckia. Different genus. Maybe? So, again, axial plate you can sort of see already. Since this is Gomphoneis, not Gomphones. Not the one that we want. There was definitely there's some Gomphonema in here. Gomphoneis. There's Cimbella mexicana. That was a air bubble. Just went by. There's another one. Big air bubble. There's an Ellerbeckia right there. The valve view of Ellerbeckia. Probably Ellerbeckia inariensis. Or Arenaria. Pretty similar to the ones that we see on Pacific Plankton Stream from the marine realm. The half-turned Gomphoneis. It's another Pleurocyra. Nice. Bella? Air bubble. Sample was made by, I think, Rihanna in my lab. Show her some techniques for not having air bubbles in it. There's a lot. They're not really a big deal. But if there was a diatom right under the air bubble, then it would be a big deal. Past a cookie stack. Ellerbeckia. That might be. Not. We're getting close to the end of this slide. Commander Shafard, how's it going? You're working on your homework. It's the weekend, Pacific. Not supposed to do your homework on the weekend. That's cool. Oh, it's due tonight. So same kind of a look to this diatom, but it's a lot smaller. Can't tell if it has, but it doesn't look like the other diatom, the Gomphoneis. Axial plate, maybe one, but I cannot see horn on this one. Possible. Blob moving for oil. A little bit better. Instead of taking up the entire screen, it just fills the box. We don't have that big apical. There's an apical Porefield, but it's not nearly as like all-encompassing. It, and also the shape is just a little different. That's our Gomphoneis. Ominous diatoms with the horns and all. Okay, you've been patient. Let's try to look at some pond material. Those photos later. Got some view shots. And so the whole time we've been basically just looking on one slide. It's sample number 4. The best of the best in this set. You hopefully see wiggly tongue. I hope we see wiggly tongue too. I like that one. Looks like a elephant nose, that one. Alright, need to get slides, cover slips. Need to probably take my headphones off to do that. Alright, so these are going to be wet mounts, and I'm just going to put it together right here while you're watching, so I'll try to do it quickly. Just blank cover slips, and or slide glass and cover slips. And I think I will try to put a cover slip on, even though some of the bigger like cover slips. Just to try to get a little bit better optics. So there's not anything being squished. Air covers. The brightness. Got us all. I'm gonna play with the settings a bit. Let's see what we can find. So all the things that we've been looking at on the stream so far are diatoms, and that's a diatom. We're zoomed way out, obviously. But you can see there's a diatom right there. And all this stuff that you can see moving around in the background is bacteria, for the most part. So if people ask me, can I see bacteria? That's what this stuff is. These larger things that you're seeing, it's oscillatoria, sort of big green blobs that you see right here. These are oscillatoria.
Pull up a chair.
Chaotic chicken, thank you for the follow. The dead rotifer. There's a little paramecium in here. Rolling around. Looking for things that move quickly. There goes one. Another one right there. More. Rolling around. That's a piece of duckweed. Big brown thing in the middle. Piece of duckweed. We're just seeing through it because light's coming from the bottom is very bright. Do not know what that is, but it looks pretty cool. So let's zoom in. It's actually alive. I think that's just being bumped around by stuff, but that's a jaggedy-edged skeleton of something. Cool. Spinner. The ciliate right there. It's actually kind of bag-shaped. Saw these on the stream last Tuesday. It was. Try to get the right scale bar on. I think it's. Oh, scale bar is missing. Not sure how to get it to move from wherever it's hiding. Yeah, it's spinning pretty good. And because we have the cover slip on, I think we can move into 20. Right. So this is a ciliate, and it's got little hairs on the sides of its body. The camera will make an adjustment here in a second. Be able to see the cilia. It's spinning really fast. Those little blurs you see around the outside edge are the cilia, the little hairs. Darken it so you can actually see that feature. Oh. And you can see it's got little hairs all around the outside edge. It's actually feeding. That's why it's spinning. It's pulling in. You see the stuff that's around. How it's all being sucked in. It's spinning because it's pulling all that in towards its mouth, and then it's just sucking up all of the bacteria. And we've been watching it from, it's basically, like I said, it's actually shaped like a bag or a little ghost, but we're watching it from the top, and it's spinning basically. There it goes. There's the actual organism. Oh. So we're sort of seeing it not in... we're looking at just from the top, basically. So it looks like a circle. but I think its mouth is pointed down. And then whenever it starts to move and it wants to go in a direction, it turns sideways and then it starts spinning, and then it's like a helicopter basically that's turned sideways. It'll start pulling in the direction that the spinning is happening. So you can see all the stuff being pulled into it, right? So that's all things that it's trying to consume. Also, you're getting very sleepy. The sound of my voice, you will go to Pacific Plankton's channel and you will follow her. Hey Pantene, how's it going? Oops. I haven't figured out to make a shout out directly for Pantene, but we'll have to just give you one manually. Pantene. There you go. Uh-oh. Did I win? I won. On mine it shows me winning. So. Oh, it spins so it can pull food towards itself. Chaotic chicken. It's got little cilia, little hairs, and it's just wiggling them. And that causes it, if it wiggles them sequentially, it causes it to spin because they have a little bit of friction. And then when it spins, it pulls everything around it towards it. So it creates a little gyre, like a vacuum, or more like a convection. And it's pulling all that stuff towards its face. And then it uses that to eat. Ordering Chipotle burritos and placing them around me so I can spin. That's a good idea. Go with the carnitas. Be my recommendation. So maximize your Hit it. Just moved a little bit. It's feasting on that bacteria, so. Alright, let's go look around, see what else we can find, yeah? It's really cute. I love these things. The first sample I've had with them in it, and I did not remember to go figure out what it was. So I don't know. It's a ciliate of some type. But also, we haven't seen it in girdle view very much. Or in side view, it just disappears when it, starts spinning on its sides. So,
Good news, everyone!
hard for me to figure out exactly what it looks like. I know it looks like a circle from above, pretty much, but that thing is kind of hard to catch when it turns. And I can't figure out what it looks like enough that I could try to ID it. Sometimes we have a ciliate special. Oh, there's a side view. There's a side view. You can see it's got like a little top. I think that's actually its mouth that we're seeing. There you go. You can see the hairs perfectly now. These are the hairs, and it spins them around. Here's its mouth, and these are the ones going around its body. So we were looking at it from above. Coronate. Yeah, it's like a corona around the mouth up here. And then it's got another set of hairs running right through the middle, basically. That's helping it spin. You can see it's got like I think that's its mouth right there. It's eating. This is a dying or dead oscillatoria right there. So that's a type of algae. Cyanobacteria, I think. Pretty cool. Like a tiny, sparkling space ghost. Spinning around. Is the lighting causing it to orient? No, I think it's just the way it spins. It sits on, sitting on the cover slip or on the bottom slide, and it was just spinning and heating. So, can I zoom in on the mouth? Yeah, I don't know if it'll look any better, but I can try. Let's see. We can get a whole lot closer than that. I could jump us up to 40x, because we do have a cover slip on. But it's a little bit tilted by some plant mass or something that's in there, so. Didinium. It looks like a beak, doesn't it? That it's spinning on? That's pretty cool. Yeah, well, it just eats a little bit. It's probably actually eating, while we're here and I lost it, it's probably actually not eating the plant, it's eating the stuff that's growing on the plant. Would be my guess. It was feasting on this bacteria, not the actual plant itself. Like a grazer, basically. Like a snail or something that's just grazing on the surface. There he is, still around. Now it's gone back to spinning vertically. Drawing stuff towards it again. It's got the little hairs and everything around us moving towards it. Okay, let's go look around, see what else I can find for us. There's another spinner right there. Right there. Not far away. Two of them pretty close to each other. The diatom? Like it's oh, you know what that is? It's a rotifer. That was the skeleton of a rotifer that we saw earlier as well. That's a rotifer. It's dead. I think it's Keratella, a predator type rotifer. It's dead in there. That's just stuff eating the body. The sample's been sitting around in my house for the last 4 days, and I haven't put it over by the windows, so a lot of the algae is probably dying. And a lot of the ciliates are probably happy, because they a lot of times will eat the dead stuff. Paramecium also looks like it's feeding. It's got cilia whirring pretty strongly around the outside edges as well. Another little one. Aww. They're friends. I think they're only friends because one won't fit inside the other one's mouth, though. That's a dead copepod right there. Copepods might still be alive, but most of them are probably dead after all the diatoms and everything else probably stopped living or is close to stop living. Although I did leave the lid off, so I feel like at least they had oxygen. What that was? A big network of bacteria in here. It's a cluster of them. They're all hanging out. Pretty cool. Do they have brains? No. They're pretty small, pretty simple organisms. I've just used the generic key, chaotic chicken. Most of them are asexual. Most of the ciliates probably just divide on themselves that way. Yeah. How long do you think the stuff in the sample could live? If I kept it a little bit more light, probably for quite a while. If you follow Del Maximum, so Del is right there. Oops, type it. He has like a bunch of jars that he keeps in his house, and like he had hydras that were living in the jars for like, I don't know, 3 weeks, 4 weeks. And then he just has other stuff he's got like a whole little community that's there that's growing in the jars, and just sort of as long as you can keep them in sunlight. I really wasn't thinking about keeping this in sunlight. I was trying to figure out if I should dump it into my koi pond or not, but it's got a bunch of duckweed at the top, and I don't necessarily want to introduce a bunch of duckweed to my koi pond. I feel like they would just cover it with duckweed. Have you ever watched the YouTube channel Life in Jars? No, but it sounds cool. I don't actually watch YouTube very much. Only time I do any like TV watching is like late at night when I'm either working out or like my wife wants me to watch something with. Do they have ways to communicate with each other? I don't know the answer to that, Robert. They might. I know that we had some, one of the scientists in my department, she was looking at euglena, and they seem to have a way to sort of communicate with each other in a way, like chemically or something. How do they know to stick together? I don't know. I have no idea. Maybe they're all just in an optimal condition, like they catch one end and then they're happy there, and maybe they found a friend and they just decided they're all gonna hang out together. I don't know. They're pretty cool that they're all hanging out right here for us. And actually zoom in on some of them so you can kind of see them up close. Their bodies are surrounded by little hairs. A nice clean view of them. Yeah, some of them probably do have chemotaxis. I'm sure they can detect food in their environment. And the little cilia are also sort of a tactile organ for them. Like that one bumped into the other one that we were watching, so you know that they can sort of sense each other by that on some level. So at the end of the stream, do you break free all that living beings? Oh, I might release them. If that's what you're asking, do I let them go? I collected these from Hawthorne Park. And so probably what I would do is bring them back and put them in Hawthorne Park. But it may be safer just to flush them down the toilet because they may have accumulated some bacterias and things. So if I put them in the toilet, they'll end up in the sewer, and maybe they'll get some more food down there. Maybe they'll end up in the Wabash River. I don't know. I try not to just kill them if I can help it. Sometimes there's not a whole lot of good choices. I guess I could keep them around for as long as I can keep it from stinking. Ostracod shell. And that's a rotifer. Find one of those other Uh... Exactly what's going on right there. Testate amoeba, maybe? Oh, yeah, it's a testate amoeba. It's crawling. Yeah, you can see it's crawling. Let's see. My battery is flashing. Want to dim it a little? Okay, I went a little too dim. You can see it's pseudopods, right there. They're coming out from underneath the, this is its house. It's the test, or the skeleton. It builds these with stuff in the environment. That's bacteria, by the way. And you can see it stretching out little pseudopods, like any other bacteria, any other amoeba. That's how it crawls around, and also how it seeks out food. So, you can see there's another one right there. There's a little leg. Comes another one. There's another one right there. And then it uses those, it kind of pulls itself along like a snail. Hey, Digital Seahorse. We got, wait a second. I see that Pacific yelled your name out, but I think I just made you one. There you go. Trying to get everybody that comes by. Yeah, I still think it's maybe a little dark. You can see the outside of the shell pretty well, but you can't see the pseudopods very well. Pods. There you go. And you can see them. Shell kind of glows like this, though. Moosey, hello, how are you doing? We're looking at the testate amoeba. Started off looking at diatoms, and then people asked if we could look at some living stuff, so I switched over to a pond sample I have. Can I measure the cilia? Maybe? For what organism? You know? Dump them in the toilet and they evolve into wombats. I don't think that's what happens, but you never know. I probably could measure the cilia if I know what organism we're talking about. Yeah, I saw, but I don't know what organism they were talking about. Some of them have little tiny cilia that are just around the outside edges, and some of them kind of had long ones, like the rotifers. Convergent wombatization. It's sort of like everything is becoming a crab. Except for its wombats. The carcinization. Crawling his way around super slow. Yeah, carcinization. Add some bananas for scale? I don't have a banana for scale, but we could put a mustache on it if you want. Now it's got a mustache. I got mustaches, and we can actually scale up the mustache a little. So. If you want a mustache. I don't have a banana though. I think he looks good with a mustache, don't you? He's dapper, yeah. That's a French curl right there. That's a seriously good mustache for a testate amoeba to have. Reference mustache, exactly. I don't have a banana though, so sorry. Let's leave our little amoeba friend alone and see what else we can find. How's that? I'm gonna zoom out. Bloop. We're also still on 20x. Zoom out, zoom out. Really zoom out. Back to 100x here. Because it's hard to find stuff when we're zoomed in that close. A little nest of plant matter right there. Bunch of those ciliates. Oh, there's a spinner. Another one of the spinners is right there. Just look like little blobs right now. That's duckweed. There's a bunch of them. They're all hanging out together again. I think they're conspiring. That's what they're doing there. Athena, hello! How are you doing? Can we get a Groucho Marx mustache? Yeah. I'll work on it next time. Any recommendations of geology channels? Volcano Doc is a good geology channel, and Rocket Sage. They're probably the two most prominent geology streamers. I think GeoJim also streams geology occasionally, and I was thinking I might put some I might bring some rock samples home and put those on the microscope for a night stream sometime next week. We might look at some limestone samples with fossils and things. That people might be kind of interested in seeing that. I actually have a geology background, a secret geologist. But don't tell anyone, or they'll want to copy my homework. Let them think that I just know diatoms and other little wiggly things. If they find out I actually know geology, then teaching a geology class right now, actually, for the summer. And then I teach another one in the fall at Strat. The air bubble's impinging on us. A byproduct of the cover slip. Oh, it's the head of a Daphnia. Its head. Somewhere on the slide, maybe there's a Dileptus hanging out. Looking for my favorite. Lacrymaria and Dileptus are two favorite little wiggly guys. At least recently. Just like how they have crazy heads. So there were some flatworms in this sample when I did it the other day, so they're probably still around somewhere. Probably not bothered by the fact that we haven't had a lot of sunlight in the jar. I haven't seen any yet. The skeleton of a copepod, I believe. Interesting. Oh, it's I think it's a Hormogonia, which is the sort of like an egg for the cyanobacteria. Melodious skeletons everywhere. No. Rhino Lion, thank you for the raid. Bringing 42 people with you. Amazing. Thank you for hopping in here. You in Pacific Plankton stream all the time. You usually raid her. Thank you for bringing some people in. We're looking at some pond samples. And slowly starting to dry up. Got these spinny guys. We got some dead rotifers. We got dead ostracods. We got paramecium. Yeah, testate amoeba. I'm looking to see what else we can find in the sample. There's a paramecium. Some of these little guys, there's really little ones in. Tell us when you get past the ads and whatnot, how your stream was. What you've been looking at and doing. I'm just here fending off questions about things, you know, wiggly things run into. I think we've gone all the way through this sample. I can make us another one. See how that goes. Oh, we're waiting. Uncle Bill! Hello! For everybody who's coming in with Rhino Lion, should give a follow to Pacific Plankton. Trying to catch up to me. Followers.
Good news, everyone!
Trying to get her there. It'll happen, but only if you give her the follows. Yeah, definitely follow Pacific Plankton. You can follow me or not as you like, but if you follow me, then you gotta follow Pacific Plankton twice. Catch up. I didn't realize we were racing, but apparently we are. So... I'm okay with losing their race. Totally fine with it. Ooh, what's this? Little worm. Hello. It looks like you're divided in half. Looks like maybe you got squished. Oscillatoria? Paramecium still? Some really little ciliates. Everybody's just hanging out in a clump by this duckweed. Another duckweed clump. There are a lot of paramecium in this sample. They're doing quite well since the things started to die. They don't seem to mind that. Victoria. Their testate amoeba. There's something new. Oh no, I think it's the same thing. One of these little spinner guys is just sideways, that's all. Go take a look. he's spinning, he's just stuck a little bit. Let's see. Let's zoom out and jump up in order of magnitude. Here it is. Kind of spinning there. See the little cilia wrapped around its body, and also that's the center feeding thing. Cool. Yeah, a lot of people say that Spicy Wand, they like the early parts of the Spore game. And it's kind of fun and you're small. Probably because they based it on things that are, you know, similar to real life organisms. So it's a race and you're the turtle. She has a great voice and yeah, a lot of wiggly microbes. That's a pretty good description of what happens on Pacific. This is the same one we were looking at. Now it's just spinning vertically. Kind of look through it. It's sitting on that little top-like structure and spinning. We answered this a little bit before earlier, Relect, but it's feeding. So it spins to feed. Just took off. Oh, it came back. That's it. The little guy that was spinning right there, that's it zooming around. Sorry. There it is. It's hard to keep up with sometimes. They turn sideways. Their spinning allows them to move through the water very quickly. So they just go bolting off when that happens. No catching them, basically. There's like a whole bunch of these paramecium in the background here. Oh, this. What the heck? What did we find? I mean, it's a ciliate. Sure, after that, what's going on exactly? Pretty alien looking. It's like S-shaped? You can see the cilia out here. Didymium. That other one was. Spinny one. Yeah, it's still spinning. You need to get the clay off of you. Oh, yeah. I don't want you to fall asleep in the studio. Did you make us anything cool? What did you make? Your brain insisted that I was Pacific Plankton? Well, I'm usually hanging out there with her, so, and she's usually hanging out here with me. You'll get a little bit of her usually if I'm around, and vice versa. That is a really weird looking guy. Yeah, so the cilia are all on this end, and then I don't know what's going on here. It's like a half-inflated sack. It doesn't look like any of the other organisms we'd seen, so... You trimmed the bottoms of some pickling crock lids that you threw last night. Oh, that's cool. Did we give Rhino Lion a shout-out? What happened? I mean, Pacific Plankton got that covered, but she did. Okay. Awesome. Well, maybe I'll go back and take a look at your stream. That would be pottery. Whole bunch of them down here just hanging out. Oh, it's a diatom. Or what that is actually. Maybe it's a Ropilodia. Yeah, I think it is. Need to make a wood lid. You have a way to turn a lid at your house there, Pacific? A whole bunch of them. What if it is an alien? Well, I feel like if it was an alien, they probably would have better things to do than to hang out at my local park. You never know. Go look around some more. The corpse of a rotifer, no, copepod, and a rotifer together, I think. Two corpses. Oh, a rotifer. Hello. Doom. So used to my following the Etch-a-Sketch on this screen that I now can't do it in the actual microscope. Maybe it's a nice park, it's possible. Now it's just crawling along. For a while there it was gonna look like it was gonna take off and do some swimming. Now it looks like maybe it might park it for a minute. Inching around on the slide. Yeah, well, I can keep up with it. That is a Deloid rotifer. It has a claw on the back end, on the foot. Trying to figure out where the food is. Hey Blizzy, how's it going? Yeah, light microscope tonight. Oh no! Don't do that! Oh. Yeah, attach right there. Attach. Grab something and attach, please. Thank you. It turned on the jets for a second. I thought we'd lost it completely. Things are going well. Good. I want it to open up its little corona now. And start feeding, but it's attached. Dragging everything around. Oh, that's this. Hello, you're very big. Are you trying to eat that? Are you honestly trying to eat that? Are you kidding me? I don't think that's gonna fit in you. That is an enormous organism, though. It's stretching over it. That's awesome. It's gonna try. I don't think it knows how big that is. Hey Pacific, is this a stentor? Did I find a stentor finally? Oh my goodness. It's trying to eat the whole thing. No, where are you going? That is so big. It just wants to eat the whole thing. And it's like, in my belly. Oh no, don't run away. Yeah, it looks like a paramecium to me too, but it's so big. It's like the mother of all the parameciums in this slide. Oh no, don't get close to that rotifer. It just tried to eat something like 5 times bigger than it. It would take you out in a second. Oh, turn down the jets. Took us straight to another. Hello. Hello. You can hang out. I like it when one takes me right to the next one. Okay, let's see. I'm gonna zoom out and then switch to 200x. Try to fix the light before this thing decides it wants to leave. You can see the cilia on that thing whirling around pretty good. Nice clean look at its whole body. It's got spikes up here, which it kind of crawls around with. Cilia on the front end. The twirling around right there. Oh no. I think it just took off on us. Oh no, it's okay. It's okay, we found it. Stay there. Making life hard. Hello. Had you for a second. There we go. That sort of walks with the back legs. Well, all the legs, really. Like walking cilia and then feeding cilia. The sample's pretty cool, isn't it? It's the magic of duckweed, I believe. You really get a sense of its how they shuffle this sort of cilia hairs around to move to, like, you know, like to cause motion and stuff. You can see the wave sort of happening on that right there. You can see how the wave moves as the light hits it. Have it perfect, and then see them like wiggle through each one, and then the ones on the backside it's using right there to crawl along the glass. See that? Pulling itself along with those legs. Snack is too big. Perfect digital. Perfect. That's a pretty silhouette. It's like it has a little tail. Right there. Pretty cool little subdivided. Not using that one to crawl either. I'm not sure what it is. Ah, battery empty. Well, I'll have to solve that. It didn't even move. Perfect. There, you can see it's creating a little gyre. You can tell it's feeding. You can actually see some of the particles going into its mouth, and then come flying back through here. See some of them kind of come through. Then Scylla? Is that the name of this one? Did you look it up for us, Pac? Oh, sensory Scylla. Okay. Got to get going again. Okay. Is it really 1 in the morning? I don't know when I started streaming, but it was a while ago. I've just been screwing around. Having fun. Hopefully everybody else out there watching is having fun. Oh, you think it's a Euploides because it's crawling? 2 hours and 21 minutes. Started kind of late, I guess. Really looking at the clock. Go look around some more. Yeah? Let this one go. See what else we can find. There's a little guy we haven't seen. Just zoomed right through. And keep up with it. A little hairy stuff at the top of the screen here. Some of the water came over cover slip and got on my lens. Little spinner guy we saw. There's another one. Didium. There's two that are attached to each other. That might be a terms of service right there. We might need to move on. That. Spinner and a cluster of these guys all hanging out. That giant paramecium went to. Gotta be in here somewhere. Probably trying to eat another entire oscillatoria. Rotifer? Hang out right there, dude. Lady, I mean. Go. Got its little head out with its mouth. It kind of pulls its mouth in a little bit, and then it pulls out those, so dark. Yeah. The cover slip. Helping. Getting caught in all those little hairs. Those hooked there. Yes, it's filter feeding with its cilia. That's exactly what it's doing. It spins a little corona at the top of its head, and then that's its mouth right there. And it will also spin the little cilia around its mouth to feed, but when it really wants to start feeding in mass, it will pull its mouth in a little bit and pull those big corona out. Turn on the big jets, basically. And trying to find some direction where that will work, apparently. There it goes. So its corona are these, and then its mouth is actually right there in the middle of those, kind of retracted a little bit. And it's got jaws that are right here. And it's got a little foot back there that's holding on to stuff. You can see it's spinning those. Sometimes we'll use them to try to move as well, so it might be trying to move rather than feed. Sometimes they use it to try to get from one place to another, but it looks like it's kind of holding on, so I'm guessing it's trying to feed. Now, they're not actually spinning. It's just doing like... So it looks like they're spinning. If they slow it down, you can actually see it, but when they go really fast, it just looks like it's spinning. But they actually just have them sort of go like that. It's pretty cool. Oh, it's Hannah. Hello, Hannah. We're looking at some rotifers in the microscope. This is a Deloid rotifer, and Pat, are you still here? Can you give Hannah a shout out? Trying to keep this thing in the field of view, but wait a couple seconds, and if it doesn't happen, then I'll do it. There you go. You should check out Hannah Rebecca Music. The great American indie musician. She plays guitar and sings. A lovely voice, and plays guitar with sometimes Joseph, also there with her, and she's new to Twitch, so she could use your help. So if you give her a follow, trying to get the word out for her a little bit. And tonight we're on the light microscope. Tomorrow morning I might do a bird stream where we just listen to birds and whatever comes to my backyard camera. And on Monday I have an SEM stream planned, so we'll look from the scanning electron microscope. And I think we're going to look at some more of Mary's samples from Wabash River on Monday. And on Wednesday, we're going to go back to the SEM again, and we'll be looking at some of those samples that I just showed earlier today. Light microscope. on the SEM, so we're going to find some of the Gomphones and Gomphoneis that we were looking at earlier. Yeah, so if you really like this, Anna, you should also give Pacific Plankton a follow. So I'm trying to get her to catch up with me in terms of followers. You could also use some more follows. This is a sample I collected from a local pond. Actually found, what was that? Oh, it's this little guy again. Our little Euploides-like guy. It's got affiliate. Follows are free, exactly. Yeah, go give them. Don't cost anything. That's sort of my plan for streaming, and I might stick in another little light stream sometime. I collected these from a local pond, and somebody had discarded a Dr. Pepper bottle. I just picked it up and saw some duckweed and sucked up all the duckweed that was there. Sample, and came home and put it into this pickle jar. Recycled it. I like to do my sampling, pick up litter at the same time. For one. Right next to each other. I was actually trying to find that giant sized paramecium that was trying to eat stuff it shouldn't have earlier. Let's see if we can find that. Oh, here it is. And look what it's doing. Look what it's doing. Look at that. It did not learn. Not one bit. That is too big for you. Just goes from one to the next. I'm just gonna try to eat everything I can see. It's still hungry. It's because it keeps trying to eat the too big stuff. And it's like somewhere around here's gotta be one of these things that'll fit. Doesn't care. Exactly it. It's gonna be like, oh, this one might fit. Will this fit? Let's see if I can find the end of it. And then it's gonna try to put the whole thing in its mouth. Hey, that one will fit. No, no, no. That one will fit. That one will not fit. No. Oh, to have eyes. To be slightly intelligent. Just the best. Be a lot less hungry. Sorry, I'm using my Etch-a-Sketch skills right now. This thing is really pretty. Pretty and dumb. The way I like my ciliates. Oh, you'll find something eventually. Just keep trying to shove things in there. Quit making me chase you. Hard. Gotta think in reverse. Very difficult. I only have 2 directions I can move it. Stop. What is that? Oh, I think it's just a piece of dead. The little one you could almost have eaten. Very invested in seeing what it's going to actually eat. Would have fit, but not eat it. Yogurt. I'm a silent viewer, but enjoy your streams a lot too. I find this all so fascinating. Thank you. Homer and his giant hoagie. An endless quest. What's happening right now? What just happened? Oh, another little guy behind. Someone feed it. It's given up. I think it just decided it was done. It's gonna sit there. Pouting. You think it's scared? I think it's just pouting. Like, nothing will fit in my mouth. Maybe it did, Froza. Like, all the big stuff won't fit in my mouth. Let's yeah, I guess it's just decided to go on hunger strike. That's alright, if it's gonna sit there, we'll zoom in on it. We'll teach it. You look at the current that thing is causing. Decided it's just gonna eat bacteria, I think. Would this qualify as a pool lake stream? Look at the gyre that thing is making, just like everywhere around it. Let's see. If I switch to 10 on this, will it make it darker? Oh, it didn't like that. Sorry, I vibrated it too much. Alright, I can make it dark. We can see that. Nope. All maxed out on dark, I think. Unless we go to dark field. We can go to dark field. Let's try it. Doesn't like the vibration when stage... That little bit of vibration it can feel when the stage switches between one and the next. It clicks. What it was doing. Alright, we're in dark field now. I need to fix my camera a little bit. Hang on. Let's see, I need to... A little too dark.
Good news, everyone!
Thank you for the follow. It's Protozoa Princess! Is it? It is. Oh, Frontonia? Maybe. I don't know. It's huge, though. And, we're just following it around. We're fanboying on it a little. Some of us are fangirling on it. Look at that giant vacuole, though. I'll balance that. Balance it with this? No. To balance it with my... depth. Actually see the surface texture of outermost part of that organism there. Looks like a fingerprint almost. So you can see that right in here. We're so zoomed in, we can actually see like the texture on the surface of the cell. It's pretty cool. You found your first stentor a few weeks ago. I keep trying to find one. I tried everything. I still haven't found one. I also haven't found any water bears that live in water. Only find water bears that live on trees. So, if you're not following Protozoa Princess, I demand that you do it. She's an artist. She paints absolutely gorgeous stuff. And it's all inspired by microscopic life. So, truly amazing. And she doesn't stream very frequently, and she also streams super early in the morning for us, I think. But we'll enjoy it immensely. Uh-oh. He's on the move. No. No, I'm too zoomed in. Don't. I'm gonna saw the looks at least. It's too hard to do in dark field. I can't tell where she's gonna go next. Okay, there we go. She's out looking for some of that oscillatoria to eat again, I think. You wish you knew things about science. You can always learn. There's always room for science. No. 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 Cool. Good view of her for a second there. There, right there. Little something behind causes the light to refract even more. Yeah, and she looks really good for a second. Too dumb to learn. Just hang out with people who know it, and it'll sink in. You'll be fine. That's my recommendation. You could just take pictures of cool stuff. That's what I do. I also know it, but not all of it. Some of it's a mystery, and it's okay not to know everything. Fine. We're invested in this. Hope she eats something that's bacteria. The more you learn, the less you know. Stay curious. Yeah, that's the trick. How many of these to make an omelet? I don't know. Let's see. Our scale is 10x no magnification, so that's this one. And so this little lady right here is about half of a millimeter. That's her length. It's about 1/2 of a millimeter. So, you know, you have to go, you're exhausted. Did you get your homework done, Pack? You turn in your homework? I'm probably gonna find something to do here soon, because I've been streaming for almost 3 hours. And it's like 2 in the morning or something for me. I have no idea. 1:30. So, yeah, 1/2 a millimeter. You could see that little one right there with your naked eye. That's a bit of duckweed. One of the tiny little duckweed leaves. That's what that is that she's resting against. So, roughly about the same size, maybe a little bit smaller. It's like Spore, but real life, yeah. Well, I think Spore was based off of real life, so when does it evolve? As soon as it figures out how to eat the oscillatoria that it tried to shove in its mouth hole, that went about as big as it is. It went about 1/2 a millimeter in, and then it wouldn't go any further. Pretty funny. So, alright. Alright, I'm gonna switch this back. So watch your eyes. First I'm gonna put this in. I'm gonna spin it over to this view. And I have more things to fix. One of them is these. Camera. Oh. Sorry to go back to the start of the stream, but you mentioned what purpose the horns serve. I don't know what those horns serve. I have no idea why they have those horns. That is a totally unknown question. As far as I don't know anybody who would even know. There's so few diatoms that have that structure, and they're so small we can't really like observe them readily. It's a diatom. That one's still alive after almost a week in my house. There's a little tiny diatom. That's a type of algae, and it's a golden brown algae. And its skeleton's made out of silica. And people don't think algae can crawl. I'm here to tell you that diatoms are algae, and they move around like snails. And this one's not looking for food. It is food. They're autotrophs. They make their own food from sunlight. It's probably happy that the microscope light's on, because it's probably getting some energy from that. Maybe you answered this earlier and I missed it, but how long do these stay alive? So the diatom that you see right here, if I were to put it back in the sunlight, it would be fine. It would live for probably a month or something like that. Somewhere in that range. They make their own food, and then the individual cell would probably just live for a few weeks, maybe a month. But it can clone itself as much as it needs to, basically, if it has food and resources required. You can see this sort of like golden colored margin. That's actually the chloroplast for the organism. They make their own energy like plants. It's not a plant. But they can clone themselves many times. And so, you know, when people ask me how long do they live, I sort of hard to say. Because, you know, are you talking about this individual? If you think about amoeba, like everybody knows, well, most people know what an amoeba is. But when the amoeba divides, diatoms do the same thing. When they divide, there was one amoeba and now there's two amoeba. And so, which one is the parent? Right? Neither of them. They both basically begin anew. And then that amoeba splits, and you have, you know, 2, now you have 3, or 2, now you have 4 if both of them split. And now neither of them are the parent, and all of the cells are just cloning each other. And if you think about it, which most people probably haven't, that means that amoeba are vernal. That means that, as you think of it as like the organism is cloning itself, and it just keeps cloning itself, and that's how it lives. They never die, right? An individual part of that organism will die, but all of the clones will just make more clones. They each live for however long they live, but like, it splits, right? So from 1 becomes 2, and it just keeps doing that infinitely. So they just live forever. Yeah. It's a through line of genetic information, yeah. It's basically an organism that lives forever. And there's a lot of organisms that are like that. They just live forever. The genes are passed from one to the next. It splits from one organism into 2, and then from 2 to 8, 4, 8, whatever. And then it just keeps splitting. So, like, if you think about it that way, they don't ever die. A cell will die, but hey, it's Comrade Bubbles. Comrade Bubbles, look what I did. Look what I did. Look what I did. Wait a second. What I did. Pack's not here, so. Ah! Got your own command. And you can just, I think you can just type it whenever. It could also make you like a VIP. We'll get on that. Then you could just type it when you came in. Shout yourself out. Comrade Bubbles is another person you should be following. Amazing, super nice, very thoughtful, and an entertaining streamer. Alright, let's go look at something besides a diatom. The stuff that you see, let's see, let's go back to that view. Those little tiny particles that you see moving around in there, those are bacteria. That's a bacteria. Bacterium. Those are bacterium. Together they're bacteria. That's what bacteria looks like. Microscopic scale. People ask me sometimes, can you see bacteria? And the answer is yes, but look how boring they are. Blobs. We don't want to see them. We can see them, but we don't want to. We'd much rather look at the wiggly little thing. There's a wiggly thing right there. Hello. Good news, you're more interesting than bacteria. Oh, look who I found. Look who it is, and look what she's trying to do again. Like, how do I get this giant piece of oscillatoria in my mouth? She never learns. She's searching for the end of it, and she's gonna try to shove the whole thing in her face again. You're losing connection. Oh, I just put people who hang out in here who are streamers as VIP. Not worried about it. It'll just happen. If you're a streamer and you're hanging out, make you a VIP. I don't care. We got like 20 of those things laying around. Thank you, Spicy One. I work very hard on my radio voice. Try to keep things very chill in my channel all the time. For the SAM streams, sometimes I've got my... You're making me dizzy. I have my students in my lab sometimes are with me, and they are entertaining. So if you want to come, sometimes they'll talk about just whatever. Fashion tips, their boyfriend, their study problems. And sometimes they're very funny. Sometimes unintentionally very funny too. That. The paramecium. Without searching for what she can shove in her face. Okay. Good news, you're more interesting than bacteria. Exactly. Oh, what part is its face? I lost where it went. But, the thing that we were looking at, they have like a little cone-shaped pocket that can open up in the side of their body, and they'll just try to swallow stuff with that. So, and there's a lot of things that kind of have that shape. It's like a little cone-shaped pocket. How many kinds of diatoms are there? The answer to that is I don't know, and I don't think anybody knows. The most reasonable estimate that people have is that there are like 1 million species.
Hey, Maori Sour.
Well, thank you for the anonymous gifted subscription. That's awesome. That went to Yogurt for that. I mentioned this earlier in the stream, but if you weren't here, I don't take any of the money that people give for subscriptions or for cheers as payment. I just pay taxes on it, and then I use it to pay for student research. So if you're gifting things in my stream or you're cheering or whatever, your money is going to student research, not to me. A little spinner. Hello. We saw one of these at the beginning. Dididium, something like that. It looks like a circle, but it's actually not a circle. It's like ghost-shaped or bag-shaped. I'm gonna see if I can switch objectives. Yeah, okay. Now we're at 20x, which is actually 200 times magnification. Because it just sits here, and then we can make some adjustments. Light. You can see the cilia around the outside, the little hairs. So the cilia that is spinning, it actually has. We saw this one earlier. We saw it in spinning on its side. Basically, it has sort of like a top shape. Of the little mouth sits on the bottom, and then it spins and it pulls stuff towards itself. You see all the stuff that's being pulled towards itself, and then it eats out the middle of that. So it's pulling food towards itself by spinning. It has a row of cilia sort of like around the middle of its body that we're seeing, and then it has another...
Hey, Maori Sour.
Thank you, Orca. Has another little set of cilia that it has around its mouth that it uses to pull the food into its mouth. So it's spinning kind of gyre is creating a convective whirlpool, and all the stuff around it, all the bacteria is being pulled towards it. And then it's got a little mouth spinner that does the same thing, and pulling it all towards its mouth. I can fix the actually on the wrong setting. Do that for it. Turn up the contrast and bring up the light. See it? Be awesome. Love these little guys. Love that they just sit there and spin. Best. For me anyway, because I don't have to chase it and I kind of watch. Like a black hole, yeah. Yeah. It's let's see, Billhog. It's using convection not centrifugal force because there is no such thing as centrifugal force. Centripetal force, which has an apparent centrifuge, but yes, what it's doing. It's using it to create a gyre or convection to pull stuff towards itself. Beach ball of death. I like that. Nice. Except for it's not circular. It's just circular because we're looking at it from the top. It's actually like barrel shaped, basically. And it also looks good in a mustache, I think. Put that right on there. Do you think? Look good with a mustache? Perfect. Yeah? 100%, yeah. The mustache will just sit there with it, so it's perfect. Forbidden root beer barrel. We like mustaches. Normally I make people pay for that with channel points, but I just like it. Sometimes I just do it. Look at it, we got this one. That one's got a mustache, and got a mustache. The rest of my emotes don't have mustaches. These ones don't have mustaches. But if you have BTTV and you go to that, there's a whole bunch more icons. I think I have another like 15 emotes on. Just the ones I showed have mustaches, I think. Not anymore with. I must ask you a barrel important question. Perfect. Perfect, Bubbles. Perfect. Just gotta fix this. There you go. Perfect. Now we've got its mustache. I'm thinking on how a fairground ride, when you spin and the spinning movement pulls things towards the center. Yeah, that's centripetal force. Or people think of it as a centrifuge, but it's actually centripetal. Physicists will tell us there's no such thing as centrifugal force. Centripetal force. Angular momentum. But really what it's doing as it spins is its little cilia are creating convection. A physics point. It needs a top hat. And like, you know, a monocle like the Diatom does. Perfect for it. I'll work on those things. We also need to make, what was the other thing I was supposed to make? Charlie Chaplin mustache or something? I'll work on some more mustache options for us. I have a different set of mustaches I use for the birds, and a different set of mustaches that I use for the SEM. So I think I've got 3 mustaches hidden as an option. It's just sitting perfectly so the mustache can stay. Groucho Marx, yeah. Groucho. I'll work on Groucho Marx. Oh, okay. I have a TKF. If you don't know the Knowledge Fellowship, you should give them a follow if you like science. They've been super supportive of me and helped me get a lot of followers, and also really supportive of all the science content streamers. So if you're interested in science content, that's a good place. And if you like Microscope streamers, you're in luck. I've made a list of those for you as well. You just click on all those people and give them a follow. They're all amazing, amazing people. They're not all scientists, but they do stream from a microscope. And really amazing streams. Yeah, the little light bulb emote. Good idea. I think I might have one slot open for emotes on I feel like we've reached a good point to find somebody to raid, or it's 2 in the morning and I'm down here chuckling. And I have a lot of friends that are on right now. And we should send you guys to one of them, I think. This has been a lot of fun. Tomorrow morning I'll probably be on, as I mentioned, doing a birding stream. It seems like it's going to be sunny. So like somewhere around 10 or 11 a.m. our time, I'll probably stream for a little bit and do close-up views of the birds in my backyard. So if you're into birds, don't know if still running. Close to closing things out at this point. He's gonna do a song for Zulu eventually, so maybe we should give him a raid. Doing music, so I think it would be a good choice. I love giving him some raids. So thank everybody for hanging out with me tonight. This is sort of like off my schedule activity when I do the light microscope streams. I don't ever really plan for them. I just come home and I want to do something fun and spend a little bit of time on the light microscope with people, talking about whatever it is we find. And yeah, it's the time change is rough, but good to see you, Protozoa Princess. I usually just see your Instagram posts and about it. So yeah, and thank you for all the subscriptions and the follows tonight. Somewhere I have a list of it. We actually had quite a few. So Mega Nura Orca subscribed with Prime account. We had an anonymous gifter that went to the yogurt. Follows by Winterheart. Oh, Joseph Radio, thank you. Popping in. Flava Fade, Russ616. We had a raid from Rhino Lion as well. Dream to Skinner's, Flip, Skip, Aquatic Chicken, Pacific Plankton resubbed, Airfare, 2 subscriptions from Burn, August Red, and Spicy Juan, and then a whole bunch of follows. Too. So thanks everybody, and thanks for hanging out. We're gonna run now, so have a good night and enjoy Numb the Geek.